All right, lesson 2, how does it change? In this lesson, we saw some quantities that change in a particular way, but the change was neither linear nor exponential. Remember, we're looking at a relationship that's different than what we've seen before. So here is a pattern of shapes followed by a table showing the relationship between the step number and the number of small squares. What distinguishes this particular pattern from linear or exponential is that we're not adding the same amount each time or multiplying by the same amount each time. Adding the same amount each time would be linear. Multiplying by the same amount each time would be exponential. However, what we do see is that the amount that our pattern is going up by each time is going to go up by the same amount. So if we wanted to go down to 4, 5, 6, well, this was plus 3, this was plus 5. Down to 4, we would add 7, and we would have 17 then. And then we would add 9, and we would have 26. And then we would add 11, which would be 37. So while it's not adding the same amount every time, and it's not multiplying by the same amount every time, there is a pattern to it. This particular pattern is called quadratic. If we look at the diagram, this is going to be interesting. If we look at the diagram, what we see as our steps change, and if we really wanted to, we could actually even draw step number 4. And just by looking at the pattern, you should be able to kind of figure out this is what it should look like. Because if you look here, we've got a square with 1 on top. We've got a square with 1 on top. We've got a square with 1 on top. And this square keeps growing and growing and growing. This is a 1 by 1 square. This is a 2 by 2 square. This is a 3 by 3 square. And this is a 4 by 4 square. Now the big question would be, what happens when we get to the nth level? Well, 1 by 1, 2 by 2, 3 by 3, 4 by 4. The nth level would be n by n plus one little extra sitting on top of it. And this right here, n times n squared. Get it? It's a square. N squared plus 1. So the relationship between the step number and the small squares, the number of small squares, is a quadratic relationship, which looks like this. We have some variable squared, which again comes from the fact that we saw squares. So that's a quadratic expression. We're going to investigate quadratic expressions a lot more in depth in future lessons. So let's take a look at this. Which pattern shows a quadratic relationship between the step number and the number of dots? What I would suggest you do is actually go through and write down the number of dots in each step and try to see how the numbers are changing. Are we adding the same thing every time? Because if we are, that would be linear. Are we multiplying by the same amount every time? That would be exponential. If you're really not sure, maybe try to draw step 4 and step 5 and look at those numbers. Which of these is quadratic?